Rust has something called tuples, or tuples? Tuples? How do you say, what is the right way to say this? Please? Hey, I did it! All right. Tuples, that's the way to say it. If you're familiar with arrays, a tuple is just like an array, although with an array you're constrained, because with an array it has to have the same kind of value for every single element. With a tuple, the big difference is the values can be of different types, and there's no restrictions. Well, are there? I don't think so. I think it could basically, whatever kind of value you want, it can even have a tuple inside the tuple. In Rust, it's really easy to start with a tuple. It's just a parentheses. That's what they use parentheses for. It's to help define and assign, saying, hey, this is going to be a tuple situation. Some languages use parentheses as a notation to define a set. Now, this is going to be different because a set is going to have unique values in a list, essentially. So that way, in a set, it still requires you to have like the same kind of data inside of it for the most part, and it will deduplicate any similar item or identical items. Tuples are different in Rust, where you can have a whole bunch of the same item in the row or a mix of data types. There's essentially one of the most foundational kinds of data pairing that you can have in Rust. Let's look real quick to see what Rust tuples looks like. You can define a tuple really straightforwardly. Actually, Rust is a strongly typed language, right? So how would you define in the notation of a strong type, sort of like Java and other strongly typed languages require you to define, in addition to the variable name, the type of variable it is. Well, in Rust, we're looking here that we see the definition is actually pretty straightforward. We just say a tuple, or whatever our variable name is, and then we immediately go into assignment. And remember, with a tuple, different than an array, you can have any kind of mix of data types that you want inside of a tuple. So as you see, we got a whole bunch of different arrays of numbers, or just, we've got 8-bit unsigned, 16-bit unsigned, 32-bit unsigned. These are different kinds of data lots of different blocks of bits. 64-bit unsigned, and then we have an 8-bit signed. It's really silly that the I stands for signed. There's got to be a reason. Can't it just be an S? Why just all right, I. You can also have floating point numbers, characters, strings, boolean values, whatever you want, you can put into a tuple. If you tried to do this with an array, the compiler would just say, nope, sorry, you can't do that. It's also neat to check this out. You can have a tuple of tuples, right? So you can have a tuple that has some embedded tuples inside of it. You can also have a tuple of a 1-unit tuple, if you wanted, and non-tuple. Yeah, a non-tuple value, anything you want. Tuples are extremely flexible. This is the kind of data structure that you want to use when you want to pair together dissimilar data types. A more advanced use of tuples in Rust is to use a tuple as an argument to a function. You can add it as an argument to a function where you define a requirement for a variable to come with two parts of data. For example, we've got a pair here with an integer and a boolean. In this case, it's a reverse. The function will essentially just swap the two values and return the same tuple with the data in a different order. It's a very simple function. This is actually really powerful capability. It lets you define a function that has a requirement with two specific. The way I kind of look at this is kind of like a struct, or sort of like a temporary struct. We're not going to be commonly implementing this struct or a specific type of struct. You need to just pass in data pairs. And where the advantage comes in, it might be very useful when exposing an API for another developer. When they're importing your crate, you can just give them the function and they just pass in the data rather than having to import another type like a struct or an enum. You could just give them, okay, just pass in a tuple and it has these two types of data. Obviously, in this case, you could also just have two arguments, right? Two different parameters, part 1 and part 2, and it doesn't have to be a tuple. This is just a for instance, for example, because this is just ways of organizing data, right? We want to be able to organize data as we're processing it in our programming language. With Rust, they give you the ability to use tuples, and this pattern is really powerful. You can also return a tuple. And when you're defining a struct, with a struct, usually you have to also define the names of the values that are associated with each of these inputs. Though you don't have to, you can use a tuple format if you so wanted. So it's a bunch of unnamed value parameters that are ordered. Another nice advanced feature that you can use with tuples in Rust is deconstruction. So you can use this pattern where you have a tuple of a whole bunch of different data types, but then you can also capture those different data types in an ordered list of variables. A will be 1, B will be hello, C is going to be a floating point, 4.5, and D will be a boolean of true. You can use this deconstruction pattern, which is nice because it allows you to more easily label the data that you're more interested in inside the tuple. Also, just in case you might run into this into the future, if you have a tuple that's longer than 12 elements, that's actually fine. It's totally fine. You can have that. If you try to print it though, even with a debug statement like this, it's just going to say error. I can't print it because it doesn't have it won't have an applied trait, for example, and it won't know how to print it beyond 12. They just didn't implement it beyond 12 because you don't usually need to print more than 12. But if you did, you would implement a trait that could do it. It's the FMT display trait. You can add this into a struct. The struct can be a tuple, like our matrix struct here. We've defined it. Even if you add this trait to it, it's not gonna go beyond 12. You need to define it yourself. You'd use this pattern here, implement format display for our matrix. In this example, it's using a struct tuple with an element of 1, and you would return a format result, which is just going to print text into, it's really simple actually. You're just essentially writing into a buffer. So this would be like a string buffer array of some sort here, and then you're going to be writing into it using the write macro. F is our pointer to the buffer, and then we just write this. It also supports variable interpolation. So if you wanted more than 12, you would write more into this. You might have a loop that just writes over every single tuple element. If you really wanted that, that's what you could do. And then you would have unlimited. You probably got to be careful though. You probably want to have some limiter on that when you're printing it out, because you could have a very big tuple and then it will just keep going. It won't stop. It'll keep printing it. So you should have a caution in there just in case, like maybe 100 or something.